Hello everyone, you're welcome to our channel once again. Today we have a typical thermodynamics question. Now let's read through the question. An air entered the compressor of an ideal air standard Brayton cycle at 100 kilopascal. That's the pressure. 300 Kelvin, that's the temperature, with a volumetric flow rate of 5 meter cube per second. The compressor temperature ratio 10. The turbine inlet temperature is 1400 Kelvin. Now, calculate the mass flow rate. We are asked to calculate the mass flow rate from this question. Now, let's read through it again. Air entered the compressor of an ideal air standard Brayton cycle at 100 kilopascal, 300 Kelvin, with a volumetric flow rate of 5 meter per second. The compressor pressure ratio is 10, while the turbine inlet temperature is 1400 Kelvin. The mass flow rate in kilogram per second is what? Now, we are dealing with a standard Brayton cycle represented in the schematic above here, where we know that the compressor works through the air by compressing it, by then passing it to the combustion chamber, then to the turbine where it is expanded. Now, knowing fully well that an ideal air standard Brayton cycle operates under ideal gas law, so therefore at the compressor, the air process will be under ideal gas law. So therefore, by using the ideal gas formula combined here, we have our PV equals mRT. That is the pressure, the product of pressure to the volume equals the mass flow rate multiplied by the R, which is the gas constant, to the temperature change. So therefore, let's pull out our parameters from this particular question. We were told to find the mass flow rate. Now, we were given the compressor pressure at the inlet, which is P1, which is 100 kilopascal. We were given the temperature of at the compressor, which is at the inlet, which is 300 Kelvin. We were also given the volumetric flow rate at the compressor entry, which is 5 meter cube per second. And we're also given these particular parameters, although not very relevant to calculating mass flow rate. Now, let's use the ideal gas law represented here, which is P1 V1 equals mRT. From there, we can resolve that our M, which is the mass flow rate, M equals P1 V1 over RT. So therefore, our P1, which is 100, multiplied by 5, which is V1, over R, which is the gas constant, 0.287, multiplied by 300. That gives us 5.807 kilogram per second. Once again, it becomes 5.81 kilogram per second. So our calculated mass flow rate of air entering an ideal air standard Brayton cycles at the particular parameters given equals 5.81 kilogram per second. Thank you.